I just want to start by acknowledging the task group members from the Michigan Department of Natural Resources, Mike Thomas, from the New York Department of Environmental Conservation, Jason Robinson, from Ohio Division of Wildlife, Matthew Faust, Travis Hartman, and Carrie Knight, from Ontario Ministry of Natural Resources, Andy Cook and Justin Trumpiscus, and from Pennsylvania Fish and Boat Commission, Mike Hosak, my co-chair, and Chuck Murray. In 2015 and 2016, can you hear it? Echoing.
It's echoing a bit, yeah. Do you want to get closer to it? Or?
Does it sound okay? No. It's echoing up here a lot. So our first chart is to maintain and update the centralized time series of data sets required for population models and assessment, including fishery harvest, effort, age composition, biological and stock parameters, survey indices of young year, juvenile, and adult abundance, and size at age and biological parameters, and fishing harvest and effort by grid. Our second charge to report the recommended allowable harvest, and our third to participate in the Lake Erie Perch Management Group Yellow Perch Harvest Strategy Evaluation process. For the purposes of management in Lake Erie, Yellow Perch is divided into 4 management units. They are management units 1 through 4 from west to east. And in this presentation, data from these management units will be represented by these colors. Management unit 1, red, 2, blue, 3, green, and 4, purple. This figure shows the total allowable catch by management unit with the 4 colored lines, as well as the lake-wide total allowable catch is the black line, and the gray shaded area is the lake-wide harvest for all management units from 1994 to 2015. In 2015, the lake-wide total allowable catch was 10.528 million pounds of yellow perch. By management unit, the total allowable catch was 1.592 million pounds in Unit 1, in Unit 2, 4.450 million pounds, and Unit 3, 3.962 million pounds, and Unit 4, 0.524 million pounds. The next few slides will pertain to our first charge. This is the lake-wide harvest of yellow perch by management unit. Again, it's shown by management unit with the 4 colored lines, and the lake-wide harvest is the gray shaded area. The values shown are for the 2015 harvest, and the percent shown are the difference or change from the 2014 values. Lake-wide, in 2015, the harvest of yellow perch was 6.918 million pounds. The highest harvest was in management unit 3, 2.782 million pounds, followed by Unit 2, 2.621 million pounds. In Unit 1, 1.122 million pounds was harvested, and in Unit 4, 0.393 million pounds. This is the gillnet harvest. It takes place in Ontario waters. In 2015, 4.456 million pounds of yellow perch was harvested in gillnets, which was a decrease of 18% from the 2014. Largest harvest was in management unit 2, 2.128 million pounds, followed by, that was unit 3, followed by unit 2, 1.489 million pounds. In unit 1, 0.582 million pounds was harvested, and in unit 4, 0.297 million pounds of yellow perch was harvested in gillnets in 2015. This is the sport harvest of yellow perch, and this is the sport harvest in U.S. waters. Ontario sport harvest is not included. The largest sport harvest took place in management unit 1 with 0.580 million pounds of yellow perch harvested, followed by unit 3, 0.377 million pounds. In unit 2, 0.127 million pounds was harvested, and in unit 4, 0.074 million pounds of yellow perch. The trap net harvest of yellow perch by management unit. This is the trap net harvest in U.S. waters. In 2015, there was no trap net harvest in management unit 1. Unit 2 had the largest trap net harvest with just over 1 million pounds, followed by unit 3 with, unit 3 with 0.273 million pounds, and a small harvest in Unit 4, 0.022 million pounds. We put it all together for each gear type. Gillnet harvest in 2015 was 4.456 million pounds of yellow perch, an 18% decrease from 2014. Sport harvest was 1.158 million pounds, a 35% decrease from the year before, and trap net harvest 1.3 million pounds, a 17% decrease. This figure shows the lake-wide harvest of yellow perch by 10-minute grid, and this is all gear types combined. The largest harvests are shown with dark blue, and the smallest harvests are the yellow grids. The largest harvests can be observed in Management Unit 3 in Ontario waters and Unit 2 in Ohio waters. This figure shows the lake-wide effort by gear type. This is for all management units combined. In 2015, over 20,000 kilometers of gillnets was fished in Lake Erie, and that was a 14% increase in effort from 2014. The sport fishery had an effort of 1.360 million angler hours of effort. That was a 10% decline in effort. And there were over 8,000 trap net lifts, which was a 21% increase from 2014. This is the gillnet effort by 10-minute grid. The largest gillnet effort occurred in Management Unit 2. And the sport effort, with the highest effort occurring in Management Unit 1. And the trap net effort, with the largest efforts occurring in Management Unit 2. This figure shows the gillnet harvest rate by management unit. In 2015, the highest harvest rate in the gillnet fishery was in Management Unit 3 at 189 kilograms of yellow perch per kilometer of gillnet, which was a 9% decrease from the year before. The next highest catch rate was in Management Unit 4 with 76 kilograms per kilometer, which was a 30% decline. In Unit 1, the catch rate was 71 kilograms per kilometer, a 33% decline. And in Unit 1, the catch rate was 59 kilograms per kilometer of gillnet, a 26% decline. These are the sport harvest rates. Again, the highest catch rate was in Management Unit 3, 0.61 kilograms of fish per hour of fishing, but that was a 35% decline from the 2014 catch rate. And the next highest catch rate was in Management Unit 4, again, with 0.54 kilograms of yellow perch per angler hour, a 31% decline. In Unit 1, the catch rate was 0.33 kilograms per angler hour, an 8% increase. And in Unit 2, the catch rate was 0.26 kilograms per angler hour, a 38% decline from 2014. And the trap net harvest rates. The highest trap net harvest rate was in Unit 3, with 90 kilograms of yellow perch per trap net lift, and this was a 43% decline in catch rate from the year before. In Unit 2, the catch rate was 72 kilograms per lift, a 29% decline. In Unit 4, the catch rate remained the same at about 22 kilograms per lift. This is the age composition of the total harvest of yellow perch by management unit. This is all gear types combined. In Unit 1, 46% of the catch were age 2 fish of the 2013 year class, followed by 26% of the fishery were age 3 fish. In Unit 2, 48% of the fish caught were age 3 fish, followed by age 5 fish, which was 18% of the fishery. In Unit 3, there was a more equal distribution of age groups in the fishery, fish being caught at ages 3, 4, 5, and 6 in almost equal amounts. And in Unit 4, again, age 3 was the highest percent of the catch with 51% of the catch, followed by age 5 fish. The 2010 year class was 23% of the catch. Broken down by gear type, in the gillnet fishery, age 3 fish comprised 34% of the fishery, followed by age 5 fish, and then age 4 and the 6 and older group. In the sport fishery, 44% of the catch were age 2 fish, followed by 27% of the catch age 3. And in the trap net fishery, 45% of the catch were age 3 fish, and 24% of the catch were age 5 fish. This figure shows the 3-year mean weight. It's the harvested mean weight. And those are the blue bars shown for each management units, ages 2, 3, 4, 5, and 6 and older. This is the mean weight that we used to calculate the recommended allowable harvest. We use a 3-year mean. The red bar at the top is the long-term average, 1990 to 2012. For most age groups, the current 3-year mean weight is near or above average, with the exception of the 6+ group, which is below the long-term average, which may be due to the sex composition of the fishery when in the past, the 1990s, when there were more larger females caught in the 6+ group. The next few slides I'm going to show pertain to our second charge, reporting the recommended allowable harvest. For yellow perch, we use an ADMB model to estimate abundance by age groups 2 through 6+. This year, we've made no changes to this model. We project age 2 recruitment for 2016 using a multi-model inference approach that is described in the Yellow Perch Task Group report, and we've made no changes to this as well this year. These are the age 2 estimates for 2016 from the multi-model inference approach. In Management Unit 1, the mean age 2 projected in 2016 is just under 40 million yellow perch. In Unit 2, it's about 27.5 million yellow perch. In Unit 3, 17.5 million yellow perch. And in Unit 4, 4.86 million yellow perch. And these figures show the recruitment trends for each management unit. The green bars are the age 2 estimates from our ADMB model, and the orange bars are the projections from our multimodal inference approach for 2016 and 2017. In 2016, age 2 recruitment is expected to be above average in Management Unit 1, and near average in Management Unit 4, and just below average in Units 2 and 3. These figures show the abundance trends for each management unit. Age 2 abundance is the blue line. In Units 1, 2, and 4, age 2 fish are expected to comprise over half of the abundance in numbers of fish. For 2016, the total abundance of ages 2 and older fish in Management Unit 1 is projected to be 56.1 million fish. Again, over half of that is about age 2 fish. Unit 2, age 2 and older fish is estimated to be 47.8 million fish. In Unit 3, 39.1 million fish. And in Unit 4, 8.4 million fish. Similar look, but just looking at the biomass estimates. In Unit 1, we estimate that the 2016 biomass is 5.2 million kilograms. In Unit 2, 5.8 million kilograms. In Unit 3, 5 million kilograms. And Unit 4, 1.3 million kilograms. The next 4 slides show our survival and exploitation rates for each management unit. The pink line is the estimated survival, and the pink dashed is the mean. And the blue line is the estimated exploitation rate, with the dashed line being the mean. And the gray shaded area is abundance. In Management Unit 1 in 2015, estimated survival was 0.559, and that was above the long-term average. In Unit 2 in 2015, survival was estimated at 0.486, which was near the long-term average. In Unit 3 in 2015, survival was estimated at 0.550, which was just above the long-term average. And in Unit 4, survival in 2015 was estimated at 0.569, which was near the long-term average. When determining the recommended allowable harvest of yellow perch in Lake Erie, we start with our abundance estimates of ages 2 and older fish, in this case for 2015. Using fishing mortality and natural mortality, we project forward for ages 3 and older fish in abundance. Add our age 2 recruitment estimates that I've spoken about to have the age 2 and older fish. And then we use the fishing rates, which are shown in the table. These fishing rates are the same as last year. In Management Units 1 and 2, the fishing rate is 0.67. In Unit 3, the fishing rate is 0.7. And Unit 4, the fishing rate is 0.3. In this table, the first 2 columns show the abundance projections for 2016 of ages 2 and older and 3 and older fish, followed by the recommended allowable harvest, minimum, mean, and max. And then at the end are the abundance projections for 2017, ages 2 and older and 3 and older. In Management Unit 1, the recommended allowable harvest mean value is 2.292 million pounds of yellow perch. In Unit 2, 2.656 million pounds of yellow perch. In Unit 3, 2.408 million pounds of yellow perch. And in Unit 4, the mean recommended allowable harvest is 0.259 million pounds of yellow perch. Lake-wide mean recommended allowable harvest is 7.615 million pounds of yellow perch, with a range of 4.779 to 10.487 million pounds. Pertaining to our third charge, so participate in the Lake Erie Perch Management Advisory Group Yellow Perch Harvest Strategy Evaluation Process. In 2015, the Lake Erie Perch Management Advisory Group continued to work on the development of updated assessment models. LEC began implementing some of the suggestions from the 2014 Technical Review Panel, including evaluating the 2-gender model, and also began looking at simulations to determine if this model is required. They also began evaluating the incorporation of recruitment data into the model. Work on the assessment models is ongoing, and the yellow perch management strategy evaluation process and development of a yellow perch management plan will follow the completion of the assessment models. To tie this back into some of the fish community goals and objectives, one of the fish community objectives for yellow perch is a productivity and yield objective, which is to secure a potential annual sustainable harvest of 13.6 to 27.3 million kilograms of highly valued fish. Also, another objective is to provide sustainable harvests of walleye, yellow perch, and other desired fishes. Our 2015 total yellow perch harvest of 6.918 million pounds contributes to the annual lake-wide harvest of valued fish. Another objective for fisheries is genetic diversity to maintain and promote genetic diversity by identifying, rehabilitating, conserving, and or protecting locally adapted stocks. By managing yellow perches according to management units, this allows for the protection of genetic diversity and locally adapted stocks. And as with the other task groups, our report will be available online on the GLFC website, and an executive summary is currently out in the hallway.